In this video, we are going to discuss about mechanical properties of solids. Starting with stress and its types. Stress is restoring force per unit area. It is given by force by area. It is neither scalar nor vector. Its unit is Newton per meter square. Normal stress. Tensile stress is produced when axial force acts per unit area. This stress results in elongation. Compressive stress is produced when force compresses object per unit area. This stress results in compression. Volumetric stress. When object is immersed inside the liquid, the hydrostatic pressure decreases the volume of an object. That results the volumetric stress. Shear stress. Shear stress is produced when force acts tangentially to a surface area. Deforming force acts tangentially to the surface. Tan theta is equal to S by H. Thermal stress. Difference in temperature of a rod results in the change in configuration of it. This produces thermal stress. Strain and its types. Ratio of change in configuration to original configuration of body. It is a unitless quantity. Strain is equal to change in configuration divided by original configuration. Linear strain. Linear strain is the ratio of change in length with the original length. It is delta L divided by L. Volumetric strain. Ratio of change in volume to original volume is equal to delta V divided by V. Lateral strain. Lateral strain is the ratio of change in breadth per diameter to original breadth per diameter. Change occurs in the direction perpendicular to the applied force. Shear strain. Angular deformation caused by shearing force is shearing strain. Tan theta is equal to S by H. For small change, theta is equal to S by H. Hooke's law. When load is applied to bodies up to certain proportionality limit, stress is directly proportional to strain. Y is equal to sigma by E, where Y is the proportionality constant named as Young's modulus. Spring force equal to minus Kx. Stress strain graph. Slope of stress strain curve will be Young's modulus. Stress strain curve. Thermal stress. Energy stored due to elastic deformation. Strain energy density is energy per unit volume. Strain energy per unit volume is equal to half into sigma E. Strain energy per unit volume equal to half sigma square by Y. Types of elastic constants. Young's modulus, which is equal to sigma by E. Property of material that tells how easily it can be stretched. Sigma and E are normal stress and strains respectively. Shear modulus. Ratio of shear stress by shear strain. Unit is Pascal. Bulk modulus. Minus delta P divided by delta V by V. Measure of ability of a material to withstand the change in volume. Negative sign indicates the decrease in volume. Compressibility 1 by B. Reciprocal of bulk modulus. Value depends on particle shape, density and chemical composition. Isothermal bulk modulus. B is equal to P. Adiabatic bulk modulus. B is equal to Yp, where Y is the adiabatic constant. Poisson's ratio. Ratio of lateral to longitudinal strain is Poisson's ratio. Relation between Y, B, eta and E. Y is equal to 3B into 1 minus 2 sigma. Y is equal to 2n into 1 plus sigma. Sigma is equal to 3B minus 2n divided by 2n plus 6B. Applications of elastic behavior of solids. When weight is suspended in beam, it draws buckling. This S is equal to weight into L cube divided by 4BD cube Y. Extension is measured in ropes of crane while load is suspended on it. That is, stress produced in rope is equal to mg by area. I-shaped beams. I-shape of beams make them excellent for unidirectional bending. Use of rectangular shaped beam is not possible in railway tracks as of improper load distribution.